Good morning to all. Today I am going to explain some more extent regarding Coulombs law. Now, in the last class, we discussed about the Coulombs law. According to Coulombs law, the force between charges in vacuum or in free space, the formula is 1 by 4 pi epsilon naught into q1 q2 by r square. If these two charges are placed in medium, force between two charges in medium, okay, that medium dielectric constant I will take it as, this is some medium whose dielectric constant we can consider as K, and now the force between these two charges in the medium formula is 1 by 4 pi K into epsilon naught q1 q2 by r square. Now from these two equations, the relation between the force between two charges in the medium and in the free space, already we discussed that the force in medium is equal to 1 by K times of force in free space, where K is the dielectric constant, Now here one application I will give regarding this Coulombs law, that there are two charges q1 and q2 are placed at certain distance in certain medium whose dielectric constant is K, and the distance between the two charges is R in the medium. This is the medium. Yeah, medium we can take it as a glass or the water. Any dielectric medium we can take. Dielectric matlab non-conducting substance. We are placing the two charges in dielectric medium. In between in glass we are placing the two charges, in water we are placing two charges, and now there exists some force between them. For the same force in between these two charges, there is some force between the two charges in this medium, and now I want the equivalent distance between the two charges in free space. For the same force in air, at what distance we have to keep the same two charges in order to get the same amount of force. For example, here the F force is acting, then F force is acting with the two charges q1 q2 in the medium of dielectric constant K, but for the same force to get the same force, at what distance we have to keep the two charges in the air, that I want to know. That equivalent distance in air I want to calculate. Here in the two situations the force is same, okay. And now I will give the question. Two charges q1 and q2 are placed in a dielectric medium at certain distance for the same force, to get the same force between the charges. Now what is the equivalent distance that we have to keep the charges in air medium, that I want to know. For that, here the condition is they gave that the force in medium is equal to force in free space. The force should be equal here and here. The force in medium formula already we know that 1 by 4 pi K epsilon naught into q1 q2 by, in medium the distance is r, then r square. Then in air the force formula is that 1 by 4 pi epsilon naught into q1 q2 by r square. But in air the distance is ra, okay. And now we can cancel some terms, then we will get 1 by r square is equal to 1 by k r square is equal to 1 by ra square. Then we will get ra square is equal to k r square. then we will get RA is equal to root K into R. This is the equivalent distance in the air in order to get the same force. Okay, this is the one application. And now let us see one more example for this. Already we know if two charges are placed in the free space or vacuum, we know the formula for the force 1 by 4 pi epsilon naught into q1 q2 by r square. When we place two charges in dielectric medium, then also we know the force formula. And now here I am giving one situation that one question for you, that two charges q1 and q2, now they are separated by some distance, but here the part of the separation is filled with a dielectric slab whose dielectric constant K and whose thickness is T. Now what is the force between the two charges? Force between these two charges I want. Then what is the force between the two charges? What is the formula to find out the force between two charges? If it is completely filled with the dielectric, then the formula is 1 by 4 pi epsilon naught K epsilon into q1 q2 by r square. Okay. Now if there is no dielectric slab, we can write only 1 by 4 pi epsilon naught into q1 q2 by r square. That here without dielectric slab, we know the formula. Completely filled with dielectric slab, we know the formula, but here the partially is there. Now the force formula, what happens? That force formula is, then we have to find out the equivalent separation in the air. How to find out the equivalent separation in the air? This is air, and this is a glass slab, dielectric slab. And now in air the distance is already appearing as the equivalent distance in air I want. Then for that r minus t distance is already in the air, r minus t, this part, and from total r you remove this dielectric slab thickness and we will get the separation, we will get the distance that is in the air. Now the equivalent distance to this dielectric slab thickness is t. To get the same force, the equivalent distance in the air medium, we know this formula. This is the dielectric slab whose thickness is r. The equivalent distance in air is, we got root k r. Here instead of r, here t is there. The equivalent distance in air become root k t, r का जगह में t है, इसलिए root k t we will get. Then the equivalent distance we will get is r minus t is already in the air. The t equivalent distance in air is plus t root k. Have you understood this one? नहीं तो ऐसे लिख सकते हैं. Now here r equivalent distance in air is root k r. R equivalent distance, r is the thickness of dielectric slab, but equivalent distance in air we got is root k r. Here t is the thickness, then equivalent distance is root k t. Yes, r minus t is already in air, already in air, and t equivalent air is root k t. Now the total air separation is, equivalent separation in air is r minus t plus root k t. Then the air separation we got. Now the formula we know in the air, that is 1 by 4 pi epsilon naught, k is not there, 1 by 4 pi epsilon naught into q1 q2 by r a square, but in air the distance is this one. Then we will get r minus t plus t root k whole square. This is the distance, because r 1 by 4 pi epsilon naught q1 q2 by r square is the formula, but r is the distance in air, but the distance in air we got is r minus t plus root k t. That's why we got this formula. This is the formula we will use in this situation. Okay, here the dielectric slab is not completely filled between two charges. Okay, and the part of space between the two charges filled with the dielectric, and the remaining part is air. At that moment this formula we have to use. And if completely filled, then we have to use the formula 1 by 4 pi epsilon naught k epsilon naught q1 q2 by r square. And this is the one application. And now I am going to tell one more point regarding this, principle of superposition I am going to tell. Principle of superposition. Up to now we discussed a principle of superposition. Up to now we discussed the force between only two charges. If system of charges are there, then how to find out the force? Many charges are there. Only two charges are there means the force on Q2 we can find out. Force on Q1 we can find out. But here if many charges are there, then how to find out the force? That is the principle of superposition we have to use. According to that, the net force, the total force on a charge, net force on a charge is equal to the vector sum of individual forces exerted by each charge. That formula is, we write the net force formula, that is F1 bar plus F2 bar plus F3 bar and so on. This is the principle of superposition. One example we will take that how we will write in vector form, that is the total force is the vector sum of individual forces. Then let us take this diagram. This is the coordinate system, and here we will take one charge Q1, and here we will take one charge Q2, and here we will take one charge Q3, and the position vector of Q1 is R1 bar, position vector of Q2 is R2 bar. These are the position vector with respect to origin. With respect to origin means their tail is at the origin. This is the vector. Okay, this is the head and this is tail. With respect to origin position vector, that's why at the origin tail will be there, at the head Q1 will be there. This is the position vector of Q1 with respect to origin, position vector of Q2 with respect to origin, position vector of Q3 with respect to origin, that is R3 bar. Now I want to find out the total force on Q1 exerted by Q2 and Q3. For that we have to join the Q2 and Q1, and also we have to join the Q3 and Q1, and what it will get here, if you want the Q2 Q1 distance, then in vector form and by using triangle law we will get this one as R12 bar, position vector of 1 with respect to 2. If we write right side like this, okay, this is R1 and this is R1 and this is R2. Okay, and what about this one I want? Okay, and for that, this one for example we will take it as R12 bar. We will write like this, R2 bar plus triangle law, P bar plus Q bar equal to R bar. R12 bar is equal to R1 bar. Then R12 bar is equal to R1 bar minus R2 bar. This is the position vector of 1 ka position vector with respect to 2, not origin, that's why its tail is at the 2. Okay, and the position vector of Q1 also I want, position vector of Q1 I want, position vector of Q1 with respect to Q3 I want, that's why position vector of Q1 is R1, but with respect to 3, that's well R13. Here position vector of 1 R1 with respect to 2, that's well R12. Q1 ka position vector, but with respect to Q2, that's well R12. Position vector of Q1 with respect to Q3, that's well R13. Okay, and R13 direction, R12 position vector of 1, that's well with respect to 2, tail is at the 2 Q2, and position vector of Q1 with respect to Q3, that's well tail is at the Q3. Okay, right. And now here, now if we consider these are all positive charges, this Q2 repels the Q1, Q2 pushes that side like this, and this force is force on Q1 applied by Q2, and this Q1 on Q1, this Q3 also applies the force, this Q3 repels the Q1 and pushes away, then that will act like this. This is the force on Q1 but applied by Q3, that's why force on 1 applied by 3, force on 1 applied by 2. And now I want net force on Q1, net force on Q1. According to principle of superposition, the total force, net force, the total force is equal to vector sum of individual forces. That means vector sum of individual forces. Individual force is on 1 2 is applying the force, on q1 q2 is applying the force, on q1 q3 is also applying the force. Okay, and if so many are there means and so on we can write this is the net force is the vector sum of individual forces. And if you want to write the F12 formula, okay, force formula in vector form already we know, in magnitude form force formula is 1 by 4 pi epsilon naught into q1 q2 by r square. 1 2 का बीच में डिस्टेंस क्या होगा इधर r12 होगा, that's why r12 square. Okay, and we have to take the distance force between 1 and 2, that's why distance between the 1 and 2 we have to take the distance between the 1 and 2 is r12, and but vector form we want to write, that's why r12 cap we have to write. R12 cap is right side, F12 is also right side, that F12 direction is along the r12. R12 cap is a unit vector, r12 cap is a unit vector. Unit vector matlab if any vector is divided with its magnitude then we will get the unit vector. Unit vector matlab its magnitude is 1, its magnitude is 1 but it is useful for only its direction. Okay, if you multiply with 1 then we will get again magnitude formula 1 by 4 epsilon q1 q2 by r square, then its value is only 1, then even the y we are indicating this one to indicate the direction. And now F13 on 1 3 also applying the force, then we write as 1 by 4 pi epsilon naught into q1 1 3 का बीच में force find out करना होगा, then further formula q1 q2 but here 1 and 3, that's why q1 q3 we should write, but the 1 and 3 के बीच में distance, then that we write as 1 3 whole square r13 whole square, but in the vector form if you want to write r13 cap we should write because F13 is along r13. Okay, now we can substitute in above equation, we will get then these two formulas we will substitute in that equation, we will get the net force as 1 by 4 pi epsilon naught into q1 q2 by r12 whole square into r12 cap plus 1 by 4 pi epsilon naught into q1 q3 by r13 whole square into r13 cap and so on. This is the final formula. If we substitute these two in above equation we will get this equation. It is very simple to substitute. Okay, and this is how to find out the resultant force. And for this I will give one application, and we know in vectors, okay, in vectors to add the vectors, okay, we have to use some laws also, we can use parallelogram law also. For example, okay, there are two forces are, this is for an example I will give, this is there are two charges are there, one is q we are placing it here, another charge q we are placing it here, and now one more charge capital Q we are placing it here. For example, they are asking to find out the force on capital Q. Okay, force on capital Q. They are asking to find out the force on capital Q. Then how to find out the force on capital Q? Then for that we have to do, this is the plus q, we principle of superposition we have to use, this is plus capital Q, this is plus small q. Okay, this is plus small q, I want to find out the force on q, net force on q, net force on q, on capital Q who is applying the force, that is the important, who is applying the force on capital Q. This is small q applies the force on capital Q, but it is a repulsion force. Okay, this is small q pushes the capital Q away because actually the force is acts along the line joining two charges, either this side it will acts or that side it will acts, but when it will act this side, if it is unlike charges then they will attract, the force will be left side. If these are like charges, this plus small q repels the plus capital Q, this side it will be there, but like charges are there means force away will be there, and unlike charges are means force towards each other will be there. And now here the force on plus q I want, that will be whether, tell me whether it is left side or right side, it will be right side because it is repulsion force. Okay, this plus q repels the plus capital Q, that side repels, pushes away, then this force we can consider as F1. Okay, F1. And next any other will apply the force, this plus q also applies the force on this plus capital Q, that will, this plus q also pushes the plus q away, this will act along the line joining away, this is F2. Okay, and now there are two charges, any other charges, if any charge is at here, that will also apply the force like this, and there are many chances, but I am not taking like that. Okay, I am taking only two charges. These are placed diagonally at the opposite corners, that is small q and small q. One more is placed at capital Q at here, and now I want to find out the force on this capital Q, force on this capital Q. Then for that, there on capital Q there are two forces are acting, and now this is a square whose side is small a. Now tell me what is the formula for the F1? F1 formula क्या होगा? F1 formula 1 by 4 pi epsilon naught. F1 is the force on capital Q applied by small q, मतलब force between these two charges, that is 1 by 4 pi epsilon naught into small q into capital Q by distance is a square. And now if you want F2 also we will write, that is 1 by 4 pi epsilon naught into, F2 is the force between these two, small q into capital Q by a square, same distance, separation between the two charges is a, here also a, that means F1 is equal to F2. F1, F2 magnitudes are equal. And now I want to find out the net force, total force on capital Q charge I want. Net force on Q, net force on capital Q applied by two small q charges. The net force, how to find out the net force? These two forces are not along same direction. One thing you should remember, if the forces are along same direction, the total force will become F1 plus F2. Okay. If the two forces are along same direction, we have to add them. If two forces are in opposite direction, to find out the net force, we have to use subtract them. Okay, we have to subtract. If these two forces are at certain angle, that is F1 and F2, then what we have to do to find out the net force? To find out the net force, we have to use the parallelogram law. That parallelogram law is under root F1 square plus F2 square plus 2 F1 F2 cos theta. Okay, and one more thing I will tell, that if once I will repeat these things, and if the forces are along same direction, we have to add. If they are in opposite direction, we have to subtract. If they are at certain angle, we have to use parallelogram law. In parallelogram law, we have this one under root p square plus q square plus 2pq cos theta, but these are all magnitude formed. Then we can use parallelogram law because there is some angle between them, okay, that is 90 degree. Then we have to find out the net force. Net force formula is right, and now we have to use the net force formula, that is parallelogram law. Okay, same direction means we have to add, opposite direction we have to subtract, at certain angle means we have to use parallelogram law. Then this is the formula, under root F1 square plus F2 square plus 2 F1 F2 cos 90. Then net force formula we will get is cos 90 is 0, theta is cos theta hoga, cos theta is angle cos 90, and cos 90 value is 0, that's why we will get under root of F1 square plus F2 square plus 2 F1 F2 into cos 90 is 0. Then 0 into something, this total term will become 0. Then but F1 equal to F2 we write, because the two forces are same, then F2 square plus F2 square. The net force we will get is under root 2 F2, under root 2 F2. But what is F2? F2 is this one, 1 by 4 pi epsilon naught into small q into capital Q by a square. This is the formula to find out the net force. Okay, here this is the method to find out the net force on a charge, okay, by using principle of superposition. According to principle of superposition, net force is vector sum of individual force. This parallelogram law is the vector sum. And if you want to solve the same problem in vector method, F1 is right side, we have to use I cap. Why I cap? Plus I cap is a unit vector, indicates positive x-axis. Plus I cap indicates positive x-axis, minus I cap indicates negative x-axis. This is F1 is along positive x-axis, that's why I cap we write. F2 is along positive y-axis, that's why we write J cap. I cap indicates unit vector along x-axis, J cap unit vector along y-axis, K cap unit vector along z-axis. This is we are writing in vector form, F1 bar and F2 bar. And I want to find out the net force now. Net force, to find out the net force, we have to use principle of superposition. According to principle of superposition, in vector form we write as f net equal to f1 bar plus f2 बार. उसी फार्मूला को मैग्नीट्यूड में लिखते तो अकॉर्डिंग टू पैरेललोग्राम ला अंडर रूट f1 स्क्वायर प्लस f2 स्क्वायर प्लस 2f1 f2 cos theta. Okay, actually at this moment I am telling how to solve the same problem in vector form. पहले हम लोग मैग्नीट्यूड में कैलकुलेट किया हुआ नेट फोर्स. नाउ I am going to calculate the net force by using vector method. Then for that what we have to do, already f1 bar f2 bar is actually it is very simple to write the f1 bar because it is along positive x axis we write I cap, positive y axis we write j cap. If it is not along, if it is in plane, how to write then, that we learned in the 11th class. Now f1 bar is what, 1 by 4 pi epsilon naught into small q into capital Q by a square into I cap plus 1 by 4 pi epsilon naught into small q into capital Q by a square into j cap. Here something is common, that we write 1 by 4 pi epsilon naught into small q into capital Q by a square. The remaining we will get is I cap plus j cap. Here we write the magnitude. If you want to write the magnitude, then we have to use the magnitude of I cap j cap. Then that is 1 by 4 pi epsilon naught into small q into capital Q by a square. Magnitude of this one, for example 1 into I, 1 into j. Here we have formula xi cap plus yj cap plus zk cap is a vector. Then what is its magnitude? What is its magnitude? The magnitude formula is under root x square plus y square plus z square. Similarly here we write xi plus yj. Magnitude formula under root x square plus y square, that is under root 1 square plus 1 square. Under root 1 square plus 1 square we will get root 2. Then we are getting the same formula. Okay, and that means either we can solve the problem by vector method, or we directly by using vectors also we can solve, or नहीं तो मैग्नीट्यूड सब्स्टिट्यूट करके पैरेललोग्राम ला यूज करके भी हम लोग फाइंड आउट कर सकते हैं. दिस इज हाउ टू फाइंड आउट द नेट फोर्स बाय यूजिंग प्रिंसिपल ऑफ सुपरपोजिशन. एंड नाउ I will explain one more thing, that one note I will tell, that if two charges, two identical spheres, there is some note point I am going to tell, that is two identical spheres. This is identical matlab though two are made with the same material and having the same radius, and they have the charges q1 and q2. These are having the charges q1 and q2. And now what we are doing, initially they have the charge q1 and q2, and they are the identical spheres. These two are the identical spheres, they have the same radius. Okay, they are identical spheres, same radius they have, but different charges. Now they are made in contact, and then separated. Then what are the new charges on two spheres? Then when they are in contact with each other, then at that moment the charge sharing will occurs between the two spheres. Then finally how they will share the charge? They are the uniform spheres and they have the they are identical spheres. That's well the total charge is equally shared among them. That's well when we will make them to contact and then separate, then the new charges on them, for example the new charge in the first sphere is q1 dash after separating, and next q2 dash is the charge on the second sphere. This is when they are in contact, and here we are separating them. Now the new charge on first sphere become, total charge is q1 plus q2, total charge is conserved, मतलब total charge firstly कितना है q1 plus q2. After joining them initially before contact the total charge is q1 plus q2, after joining also, after separating also, then the total charge should be same, because charge is not created, charge does not destroyed. It can change from one form to another form. It can transfer from one body to another body, but it cannot destroy, it cannot produce newly produced. That means the total charge on isolated system is remains constant. And now this is the, but the total charge is equally shared, then they are the identical, that's well q1 dash is equal to q2 dash. Then the new charge we can substitute q1 dash as q2 dash, q1 plus q2 is equal to q2 dash plus q2 dash, then we will get as 2 q2 dash. Then the charge on the first sphere is q2 dash is q1 plus q2 by 2, and the charge on the second sphere is also q1 plus q2 by 2. Total charge is equally shared. Total charge is equally shared. Now total charge on this one q1 plus q2 by 2, the total charge on this one is q1 plus q2 by 2. दोनों ऐड करते तो q1 plus q2 होगा. Initially also q1 plus q2. दोनों ये भी ऐड करते तो q1 plus q2 आएगा. इधर q1 plus q2 by 2, इधर q1 plus q2 by 2. Then दोनों ऐड करते तो 2 into q1 plus q2 by 2. 2 to cancel होगा. Then we will get q1 plus q2. That means total charge is remains constant before contacting and after contacting. Okay. And what is this? In this I will repeat. When two identical spheres having the charges q1 and q2, and they are made in contact with each other, and after that they are separated with each other, then the new charges on each sphere become q1 plus q2 by 2, q1 plus q2 by 2. मतलब total charge is equally shared. What is the total charge? q1 plus q2. Equally shared मतलब दो जगह share करना होगा, because two spheres, the two spheres equally shares the charges. Total charge is q1 plus q2, two spheres equally shared by 2 by 2, then q1 plus q2 by 2, q1 plus q2 by 2. And now I will explain one problem. How much positive and negative charge is there in a cup of water? How much positive charge and negative charge is there in a cup of water? How much positive and negative charge is there in a cup of water? In a cup of water. This is our question. Okay. How much positive and negative charge is there in a cup of water? Okay, let us consider the mass of cup of water. We can consider solution. Cup of water mass, we can consider the cup of water mass as 250 gram. Okay, and water molecular weight of water is H2O 2 plus 16, that is 18. And now we want to find out the total positive charge in cup of water, but first we have to find out the total positive charge on one water molecule. In one water molecule, how much positive charge is there, that much negative charge is there, because water molecule is a neutrally charged. That's when positive charge and negative charge is equal. The positive charge, positive or negative charge in one water molecule. In one water molecule, how much positive charge is there or how much negative charge is there? Then for that we know charge is conserved. Charge is conserved. Then Q is equal to Ne we will write. Okay. And in one water molecule, how many protons are there? One proton has E charge. N protons are there means Ne charge. Then how many protons are there in water molecule? Then in water, in oxygen atom, there are oxygen atomic number कितना है 8, it means 8 protons are there. Hydrogen atomic number कितना है 1, that means 1 proton is there. But H2 2 hydrogen atoms are there, so 2 protons. Here in oxygen 8 protons, then total 10 protons are there. 10 protons. 1 proton charge E, then 10 protons charge. Then that is charge on water molecule. Positive charge on water molecule is nothing but protons charge. In one water molecule, how much protons are there? 10 protons are there. 10 protons charge only positive charge on water molecule. Then 10 into 1.6 into 10 to the power of minus 19. We will get 1.6 into 10 to the power of minus 18 coulomb. This is the positive charge on only one water molecule. But in cup of water, on one water molecule we got the positive charge or negative charge. but in cup of water I want to find out the positive charge or negative charge. For that cup of water, how many molecules it can contain inside, that I require to know. Then for that we have one formula, that is number of moles formula. Then number of moles is weight by molecular weight by Avogadro, number of molecules by Avogadro number. You should remember, one formula is weight by molecular weight, other formula total number of molecules by Avogadro number. Then molecular weight already we know that small m is 250, molecular weight also we know 18. Then n by Na we know 6.023 into 10 to the power of 23, Avogadro number already we know in chemistry and in physics also. Then we will get the number of molecules present in the cup of water is 250 by 18 into 6.023 into 10 to the power of 23. This many molecules are there in cup of water. In one molecule this much positive charge is there, and this many cup of water has this many molecules. Then the total positive charge or negative charge on cup of water is nothing but then the total positive charge on all water molecules which are present in cup of water. Then total positive charge in water molecule I want to find out. Then the total positive charge is total positive or negative charge in cup of water. Then for that the total positive charge is capital Q is equal to total charge. Here we know one molecule has this much charge, we have this many molecules, that's well here one molecule has a small q charge and n molecules we have in cup of water. How much charge it has? N into small q, then capital N into small q. Then capital N into small q, how capital N value already we know, then that is 250 by 18 into 6.023 into 10 to the power of 23 into, and then charge small q value already we know here 1.6 into 10 to the power of minus 18. Then if we simplify this, then we will get the answer, that is 1.34 into 10 to the power of 7 Coulomb. This is the total positive charge or total negative charge which is present in cup of water. And this is the one problem, and like this we have to solve the problem. And now thank you very much to each and everyone, and subscribe my channel, comment and share to your friends. Thank you, thanks a lot.